Hello, my name is Nick Sturts, and I chose to do this presentation on an article I found in the CHI 2014 proceedings. That article is called Under Pressure, Sensing Stress of Computer Users. And in this presentation, I would like to give a quick introduction to the article, and I will be looking at GOMS and seeing if GOMS would be an accurate data tool to use for this experiment. Recognition of when a user is stressed can be very beneficial. When a user is stressed, it can be very frustrating, and there can actually be negative health conditions that come from being in a stressed environment. So if a system can detect that stress, they can start to actually make changes to the interaction, the interface of the system, which can help to reduce the amount of stress. And some of those changes could be delaying of system updates, which can cause pop-ups or reboots. It can actually reduce the number of unnecessary notifications, or the system could even recommend that the user take a break or shift their focus to another item that is not as stressful. Stress detection is difficult. It's either intrusive with a lot of sensors, or it requires users to stop their task and answer questions. So the holy grail of stress detection would be a system that's unobtrusive and does not require that the user shifts their focus. That's what this article was studying, and analysis has shown that keyboard strike pressure can increase when stressed, as well as mouse movements and mouse button pressure. So this study was going to see if we could use those two pressures and the mouse movements to figure out if the user is stressed. And as I said, stress recognition is difficult to do unobtrusively. There's a couple of ways that researchers have done it in the past. It's usually self-reports and measures of psychological signals, and that is as the user is doing a task or after a task is complete, the researchers will ask them questions, but that removes the user's focus from their tasks and can actually modify if the task was stressful and then they stop to answer these questions, that could modify their mood and skew results. Another way researchers have tried to detect stress is by using stress hormones in blood or saliva, or looking for other physiological signs such as pupil dilation or skin temperature. The problem with those are they were very intrusive. The users have to give blood or saliva or have a lot of sensors on them, so it can also skew results, possibly making the user more stressed. This study was a within-subject laboratory experiment. They had 24 subjects ranging from 17 to 60, and the input devices used were a pressure-sensitive keyboard and a capacitive mouse. They did also have a wristband with biosensors embedded, and that was loosely held to not interfere. And the users were given 3 tasks: transcribing some text, expressive writing, where they discuss a relaxing memory from their past, and then also a mouse clicking exercise. Being a within-subject experiment, each of the subjects performed the 3 tasks once in a relaxed environment, in a relaxed mood, and once in a stressed mood. After each task, the users self-reported stress levels on a 7-point Likert scale, and that was so that the researchers could gauge whether or not the users actually felt stressed. And when they were finished and began to compare the results, They actually did find that a pressure does increase when a user is stressed, and they did note though that when the users that were asked to write about the relaxing memory first, their stress was actually less. So that was, but it was still that the pressures on the keyboards were increased over the non-stressed environment. So that actually does show that a keyboard could possibly be used to detect the level of user stress. Now, when looking at the mouse, though, they were unable to infer any findings, and the main reason they thought was that users were able to learn during their first mouse click, and so the second mouse click exercise, the second time they tried it, it was actually much quicker, and they had the learning effect from the first time, and so they couldn't infer anything from this experiment, but they did say possibly a longer training period, a longer mouse click task could help to overcome the learning effect. So when considering this experiment, it sounds like a very good experiment that we could apply the GOMS model to, because GOMS is goals, operators, methods, and selection rules. Each subject was given a task, a goal. They performed actions to get to these goals, operators, in a set order, methods, and there could be multiple ways, so they had to select. GOMS can actually be used to quickly calculate the cost of an interaction, which is what this study was trying to do. How quickly were people typing? How quickly were they clicking their mouse? That, along with pressures from the keyboard and mouse, would show if they were stressed. The only problem with this is that GOMS actually does not handle unpredictability of users very well, and unpredictability can come from many sources, such as fatigue, or in this case, and fatigue can in this case be caused by being in a stressed environment, which is the core of this experiment. And so being in that stressed state could cause fatigue, which could then cause the unpredictability, which GOMS does not handle well. GOMS also requires a pretty rigid expert level of user who knows what to do, when to do it, and does not allow for slips or errors very well. It requires the level of consistency to be accurate, but in a stressed state, users would be more prone to these errors, and that could cause the GOMS data to be skewed. Everyone has certain levels of errors anyway, but again, in this stress state, those errors could be greatly exaggerated. Due to the fact that the users are in a stressed environment, which can increase fatigue and the number of errors, I don't feel that GOMS would be an appropriate tool to use for data modeling, data gathering for this experiment. It could possibly be used to gather auxiliary data about the amount of time a user takes to perform a task, but it could not be used for the main. In this presentation, I referenced the article Under Pressure, Sensing Stress of Computer Users from the Proceedings of the CHI Conference 2014, and also the book by Carroll, HCI Models, Theories, and Frameworks Towards a Multidisciplinary Science. Thank you.